process.
What is object-oriented programming? A style of programming characterized by the identification of classes of objects closely linked with the methods, function which they are associated. Why is object-oriented programming important? Now that we know the answer to what is object programming language, let us explore why is it important for developers. First, organized code. The code structure is more organized under OOP. As a result, developers find it easier to understand and maintain code. Second, real-world modeling. Every developer can model real-world entities and their relationship directly in code under OOP.
Reusability. A coder can resume objects in OOP across different parts of a program or in other programs. This feature is important because it helps save time and effort. Fourth, conformity. The consistency allows developers to afford standardization, which makes it easy to learn and share code across the community. Fifth is collaboration. Multiple programmers can work on different classes or objects in OOP simultaneously.
It's a simple text-based vector game movement in Java. Players choose a pet type, pig, bear, or panda, and give it a name. The goal is to keep the pet's health from reaching zero by feeding, sleeping, and playing with it. The game includes a timer that adds a time constraint, making it more challenging. If the player doesn't choose an action within 10 seconds, the pet's health decreases. The game ends when the pet's health reaches zero. Players can interact with the pet by choosing action, feed, sleep, play, or exit to maintain its well-being. This Java code defines a virtual pet simulation, game where the user chooses a pet, pig, bear, or panda, and interacts with it by feeding, sleeping, and playing. The pet's health decreases over time, and the user must respond to prompts within a time limit to maintain the pet's health. If health reaches zero, the game's end. The code uses a time process and switches statement to handle user inputs and simulate pet interactions. The game includes a timer that adds a time constraint and makes it more challenging. This Java code defines a virtual pet simulation, game where the user chooses a pet, pig, bear, or panda, and interacts with it by feeding, sleeping, and playing. The pet's health decreases over time, and the user must respond to prompts within a time limit to maintain the pet's health. If health reaches zero, the game's end. The code uses a time process and switches statement to handle user inputs and simulate pet interactions. The game includes a timer that adds a time constraint and makes it more challenging. Package and imports. The code is part of the Tamagotchi package. It imports classes from the Java Utility package, random, scanner, and timer, as well as timer task. Utilizes the timer and timer task classes to implement a countdown timer. User must respond to the pet's need within a time limit to avoid deterioration. The main class is named. It has some static variables like health, count, timing, and answer. Define the characteristics to virtual pets such as type and name. Instantiate pet objects based on user input. A nested class pet is defined with attribute type and name. An array, status, and a random object are declared. Main method is the entry point of the program. It initializes variables, display an introduction, and prompts the user for play or exit. If the user chooses to play option 1, it prompts the user to choose a pet type and name. A pet object is created based on the user's choice of pet type. The user is informed about your choice pet's type and name. The game starts with the user having 20 hearts and a timer set for 10 seconds. A timer pass is scheduled to run every second, documenting the count. If the user answers a prompt, the counter is adjusted. If the timer reaches 0 and no answer is provided, the health decreases. A loop runs while the pet's health is greater than 0. The user is prompted to choose an action with their pet feed, sleep, play, or exit. The chosen action affects the pet's health positively or negatively. The main game loop allows user to interact with the pet through a set of actions. User can feed, let the pet sleep, play with it, or exit the game. The scanner used for user inputs are closed to prevent resource leaks. User choices are captured through the scanner class, providing a simple, interactive experience. This class contains methods related to the action of the pet, eating, sleeping, and playing. This method print messages related to the respective action. Display various status message reflecting the pet's need and emotion. Messages prompt user to feed, put the pet to sleep, or play with it. The pet's health is a critical parameter. Action taken by user affect the pet's health positively or negatively. The chief class provides introductory and feedback messages. It sets the tone for the game and gives context to user action. Gameplay. Initialization. User choose a pet type and give it a name. The game starts with the pet having 20 health points and a countdown timer. Timer countdown. User must respond to the pet's need within a given time limit. Failure to respond deducts health points. User action. User can feed, let the pet sleep, or play with it. Each action affects the pet's health positively or negatively. Game over. The game ends when the pet's health reaches 0. User receive a game over message with the pet's final state. This game is an example of object-oriented programming, or OOP, because it utilizes key principle and concept of OOP, such as encapsulation, inheritance, and abstraction. The fundamental concept in OOP is the organization of code into classes and the installation of objects. From those classes, index the code, the pet class represents the blueprint for virtual pets. It encapsulates attributes like type and name, and instances of this class such as pet object are created based on user input. This follows the class object paradigm of OOP, enabling the modeling of entities and their behavior. Encapsulation. The pet class encapsulates the properties of type and name, providing a way to represent and bundle these attributes together. The use of private variables health, count, timer, and answered, and methods within the sum class encapsulate the internal state and behavior of the game, preventing direct access from outside the class. Encapsulation is a key of OOP principle that involves bundling data and methods that operate on the data into a single unit. A class The pet class encapsulates the characteristic of the virtual pets, providing a clear interface for interacting with pet objects. It shields the internal implementation details from external entities, promoting a modular and organized code structure. Inheritance. The pet class demonstrates inheritance by having a common base class for different types of pets. Each type of pet inherits common properties and behavior from the pet class. The sum class itself doesn't explicitly showcase inheritance, but it could be extended in the future to include more features or different game modes. Inheritance allows a class, subclass, to inherit the properties and behaviors of another class or superclass. While the code doesn't explicitly showcase inheritance, the potential for it is evident. For example, a more complex version of the game could introduce different types of pets with shared characteristics. By extending a common pet, superclass specific pet types could inherit common attributes and behavior while allowing for customization. Abstraction. Abstraction involves simplifying complex systems by modeling classes based on the essential properties and behaviors relevant to the problem domain. In this game, the pet class abstracts the concept of a pet, focusing on its type and name. The sum class abstracts the game logic, providing an interface for interacting with the pet and managing the game state. The details of the game implementation are hidden behind this abstraction. Abstraction involves simplifying complex systems by modeling classes based on the essential features and ignoring irrelevant details. In this code, the Chi class abstracts introductory and feedback messages. It provides a high-level interface for communicating with the user, abstracting away the specifics of how these messages are implemented. Abstraction promotes code modularity and readability. The game is modularized into classes, sum and chi, each responsible for specific functionalities. Sum manages the game state, user, input, and timers, while chi contains methods related to the pet's action and introduction. The code is structured in a modular manner, with separate classes, pet and chi, handling distinct aspects of the virtual pet game. This modularity aligns with OOP principle, facilitating code organization, maintenance, and potential. Future extension. Each class serves a specific purpose, promoting a clean separation of concern. Polymorphism allows objects of different classes to be treated as objects of a common superclass. While the code doesn't explicitly demonstrate polymorphism, its design hints at the possibility of introduction polymorphic behavior in future. Enhancement, for instance, different pet types could share a common interface, enabling them to be treated uniformly in certain aspects of the game. While not explicitly demonstrated in the provided code, polymorphism could be introduced by extending the game to handle multiple types of pets with their unique behaviors, allowing for more flexible and extensible code. By applying this principle, the code becomes more organized, maintainable, and scalable. OOP allows you to model the real-world entities in your program more naturally, make it easier to understand and extend and modify the code. The provided Java code embodies key object-oriented programming language principles including classes, objects, encapsulation, and the potential for inheritance and abstraction. These principles contribute to code organization, reusability, and maintainability, aligning with the core tenets of OOP. Understanding and applying this principle enhance the clarity and scalability of the code. making a robust foundation for building and extending virtual pet games. The provided Java code exhibits a connection with Object-Oriented Programming or OOP principles, which is evident through various elements such as classes, objects, encapsulation, and inheritance. A detailed exploration of this aspect can provide a comprehensive understanding of how OOP is implemented in the code.